Welcome everyone to the last presentation of today. My name is Lubos Mlcoch. I work at OSIsoft as Cybersecurity Advisor for customer success. And the topic for today is securing and hardening of your PI system. So thank you for coming today. So first, let's look at our agenda quickly. So first, we'll do some short introduction into why cybersecurity is important and how to approach it, how to set up our expectations. Second, we'll look into the sliding scale of cybersecurity. Next, we'll look into what I call Big Four of cybersecurity. These are measures that you can put into place to really improve your security posture. And finally, we'll look into cybersecurity data sheets, which are a framework and provide an anchor for your cybersecurity approach and really help you assess how you are doing with cybersecurity. And we'll end with a call to action, which is a challenge to all of you. So first, I like to start with 3 laws of SCADA Security. This was listed by Dr. Andrew Ginter from Waterfall Security in his book, SCADA Security, What's Broken and How to Fix It. Now, this applies to SCADA security, but I think the same principles apply also to cybersecurity in general. So the first law is that nothing is ever 100% secure. Second law is that all software can be hacked. And the last law is that every piece of information can be an attack. Now, I'm mentioning this because we need to set expectations on how we should approach cybersecurity. So our expectation should not be to build a system which is completely secure and impenetrable. These systems do not exist. Our expectation instead should be to build our security posture high enough so that attackers think twice about trying to attack our system and overcome our defenses. So we also need to apply our security measures based on the threat spectrum we are facing. So if you look at the top, we have nation states. These are state-sponsored groups. They have unlimited resources, and they are able to craft targeted malware. So an example of that could be Stuxnet, which hit the news some years ago. And basically, this proves that if somebody wants to spend enough resources and money, they'll get you. And on the bottom, we have some corporate insiders. These are just people who exploit weak permissions or misconfigurations. So for most of our industries, the threat spectrum is usually somewhere in the middle. And what that means for us as SPI admins and cybersecurity people is that we can really prevent many of these issues with just proper baselining and configuration of our systems, which is good news. Now, how do we start? How do we start with cybersecurity, and how do we know where and how to spend our resources, our time and money? So what I like is this model of a sliding scale of cybersecurity. This was put forward by Rob Lee from the SANS Institute. And it has 5 building blocks. So on the left side, this is where we get the most value for our effort spent. So it's architecture, passive defenses. These 2 are really critical to get right. Once we manage to make these 2 okay, or to the level that we want, then we can move on to active defense, which is in the middle, or even intelligence and offensive actions, but we do not recommend that you take any offensive actions against your own attackers, because it's really difficult to attribute cyber attacks to specific groups, and it doesn't help us secure our systems in any way. So now let's take a closer look at the architecture stuff, which is the blue block on the left. So we are at PI World, so most of you, I'm assuming, are actually PI users or are running PI. And just by running PI, we get a huge security advantage over people who do not. And the main reason for that is that thanks to PI, we can move all these people who usually need access to our critical systems outside of our security perimeter. The reason for this is that they actually need access just to data, not to the actual assets. So by using the PI system, we still provide data they need to do their own jobs, but they don't need to directly interact with our critical assets. But even with the PI system, there could be some bad architectures or bad topologies like this one, where we have all our users in the enterprise network on the right. These are users who typically have access to the internet, email. They basically present the largest attack surface out of all these networks. And they directly connect into the control network where we have our PI servers, our data collectors, and our data sources. So even though this goes through a couple of firewalls, this is not really a security boundary, and it's something that you should never go for. A better topology is this one, where we actually put PI in the middle between our critical assets and our enterprise users. So this basically goes back to the first slide, showing where PI really has its value, where we can limit access of these users, so they only connect to data archive or PI server in the middle. They have no access to our actual assets in the control network. And even better is if we put PI vision into this setup, so users don't even connect to PI data archive directly in this case. They just go to PI vision, and then we go from PI vision through data archive to our interfaces. So this is just a summary slide of the architecture. This is what's our reference architecture that's used by our customers, especially in the United States, who need to be compliant with NERC standards or NIST compliance requirements. So here we actually have two PI systems, one in the middle and one in the corporate network, and then we use a PI system connector to replicate data between those two systems. So all user interaction actually happens on the copy of the PI. So we again add additional layer to the whole kill chain, going from external access to our field or control center. So that was about architecture. Now let's move on to some passive defenses that you can put into place. I call this the big four, because these four things that you can do are free to do, and they really improve your security posture by a large margin. So the first one is to make yourself a smaller target. You want to be a small target that's very difficult to hit. And the best way to do it currently in the PI system is to run your PI servers on Windows Server Core, which is a Windows server without any graphical user interface. So it's fully managed by console, especially PowerShell. It has fewer services, fewer applications. There's fewer things running in general. It's also cheaper to run because you don't need so much disk space. And there's less critical patches and maintenance. As we can see on this screenshot, which is from a Microsoft YouTube video, where we see a comparison between the pinkish full desktop experience and the green server core. So you can see there was about 3 times less critical patches for the core edition. And then, of course, even if you have Windows Core, you can further disable certain services that are not necessary for the programs that you are running. So we can do additional hardening even on server core. And all our main products, Data Archive, AF, connectors, Web API, actually all work on server core. So this is something I really wanted to highlight in this presentation. Now, I know that from my own experience doing tech support that most of our customers are not using a server core. They are using the full desktop experience. And I think one of the main reasons for that is that they are not used to using console or PowerShell for maintenance and administration of the system. So that's a difficult transition to make, but once you do it, you really benefit greatly because you can scale out your maintenance very easily and you are not dependent on any UI changes. But in the meantime, while you are making this transition, what you can use is the Windows Admin Center from Microsoft. It's a free tool, browser-based, and it actually allows you to manage your servers remotely. So say you have 5 server core servers running PI, AF, and other OSIsoft applications, and you can manage all of them from central location, from a workstation running this Windows Admin Center. It's using PowerShell remoting in the background, but you don't actually have to type any commands. You have a nice UI here. You can uninstall applications. You can set firewalls, file permissions, basically anything. It's an effective replacement for remote desktop. There is no need to remote desktop ever to PI Data Archive with this tool. Number 2 on the big 4 list is whitelisting. Now, here we have a comparison between whitelisting and blacklisting. So on the left side, we see that if we only have applications A, B, and C, then it's quite similar. With blacklisting, by default, we allow all applications to run, and then we specifically identify applications we do not want to allow to execute. So in this case, we only allow application B by blacklisting. The same goes for whitelisting, but there's a huge difference. By default, no applications are allowed to run, and we have to make an exception for application B. So, but in this case, it's about the same. It's not a huge difference. But as you can see more on the right side, as the number of applications grows and gets bigger, with blacklisting, you are just playing catch up. You are trying to identify all the bad stuff that could be on your system. With whitelisting, you still have the same principle where you deny all applications from running and only allow certain applications to execute. And they do not go against each other. So you should always start with whitelisting. It's more effective, but you can also complement the solution with antivirus or any other blacklisting solution. Here, I wanted to highlight a couple of knowledge-based articles that OSIsoft offers on this topic. First one is whitelisting with Windows Defender application control. So Windows Defender application control is available since Windows 10 or Server 2016. It was known as Device Guard before, then Microsoft changed its name. And the way this works is that you basically create your baseline image. So let's say you would install a clean operating system, put PyData archive on top of that, and then you only allow Microsoft and OSIsoft files or executables to execute on your system. All other files would be disallowed. The second way here in the middle is whitelisting with AppLocker. AppLocker is an older technology, so it's available even on older operating systems, but it doesn't work with Server Core, and it's got some other limitations compared to the Defender control. So again, it's not ideal, but it could be used in combination with Windows Defender, so you can have both solutions active at one time. And the last article is whitelisting Pi applications based on catalog files. The reason for that is that at OSIsoft, we sign all our files with a digital signature so that you can check integrity of the file and verify that it's actually coming from OSIsoft. And these digital signatures can also be used in whitelisting rules. So you can very easily set up a couple of rules and allow our applications to be able to execute. But we also use some third-party files or open source files in our applications that we cannot sign for legal or technical reasons. And for these files, what we provide are so-called catalog files. So you download these from our website, you deploy them on your system, and then once they are deployed, it's as if those files were signed by OSIsoft digital signature. So that makes whitelisting much easier for our applications. And the only reason I'm mentioning built-in features and not any third-party solutions here is that all of you can use these. They are not they are available to everybody. It's just a Windows feature. But of course, if you have a partner or vendor who offers whitelisting solutions, you can go for that as well. Number 3 on my big 4 list is upgrade your software. This is very critical because if you want to take advantage of all the work that our developers are doing, you have to keep up to date with the software. And the same goes not only for OSIsoft, but even Microsoft and other stuff. For example, we have Windows 2008 coming to end of support in January 2020, and that's when many of our customers want to upgrade. But that means they've been running an old system for years, and they haven't updated. So at OSIsoft, what we are striving to do is we add compiler flags when we are building our software as they become available. So an example for that could be the Spectre issue that Intel CPUs had a few months ago, maybe a year ago. And then we had a compiler flag added by Microsoft that actually fixes the issue, and we built this into our products. Second, we continue to apply least privilege to our services. So less of our services are now running under a local system, and we switch over to more secure anti-service built-in accounts. And lastly, we've also added some support for Windows Core. So please keep up to date with your software. And finally, number 4 is the principle of least privilege. So we only want to give our users the access they need to actually do their own job. Not everybody needs to be an admin in the operating system or a PyAdmin in the Pi system. So by following the role-based access rules, we actually give users only the access they need. So some of your users maybe need only read access to certain subsets of data. So the best way to do it in Pi is to actually enforce Windows authentication. So move away from the old PyTrust and explicit login authentication methods and go for Windows authentication. There's many benefits to this, even though the initial implementation cost is quite high, because especially if you have to move away from existing PyTrusts, it's going to take some work. But once you finish, you get many benefits. One of them is that with Windows authentication and modern Pi system, meaning 2015 or later, you get transport security. That means that the channel between your data collection or any client and data archive is encrypted, meaning it's very difficult for anyone to actually get in between those two components and try to steal your data or modify data in transit. We also get auditing capabilities with Windows authentication. So you can easily correlate your Pi message log with Windows event log and know exactly who logged in to Pi data archive and when. You also see what kind of application they have and what kind of access. So for industries like pharma, this is critical to be able to audit the connections. And then I wanted to highlight two tools, again, free open source tools you can use to assess how you are doing. So the first one is AHA project. It stands for Attack Surface Host Analyzer. It's developed by Washington State University in the United States. It's available at these links if you want to check it out. And the way it works is that there's two parts. One is the scraper, which you can see on the left, and the second is the GUI, graphical user interface, on the right side. So the scraper scans your system, looks for all the processes that are running on your system, the properties of these processes, what kind of ports they have to open the communication to external network or even internally, and then it saves this information into a text file. In the second step, you take this text file and you can run it through the second component, which is the GUI. And then in the end, you get something like this, where on the left side, we have a pretty old Windows 2008 server running with unnamed data historian, non-Pi. And on the right, we have Windows Server Core 2016 with Pi Data Archive 2017. And just by visually inspecting the difference between those two pictures, you can tell there's a big difference. And the score reflects that fact. So if you look at the external and internal attack surface score of the old system, it's about 8–9%. The one on the right, running the core Windows server and new Pi Data Archive, is about 80%. So 10 times increase in attack surface score. The second tool I wanted to highlight is actually from Microsoft. And again, it's open source, available on GitHub. And the way this one works is that it takes a snapshot of your operating system. It looks at stuff like registry, files, certificates, user groups, and then saves it into a file. This is your baseline file. Then over time, stuff on your computer is going to change. Maybe you are going to install new software, or there's going to be user-made changes. So then you do another scan and compare it to your baseline. And that way, you can see exactly what was changed in the system. Because many times, what happens is that we install new applications, but there's so many undocumented changes it's actually doing in the background that we have no idea about, that this tool provides a visibility into. And we can actually check what was changed. And then maybe decide to look a bit more closely and inspect why that change was made and if it's actually necessary. And this can be scaled out, so it's not only done in graphical way, but you can use scripting to run it on many machines at once and then save it to an output HTML file to really see what's happening on your systems. And now I want to take a little segue into the chemical industry. In chemical industry, when you buy a chemical product, it usually comes with a safety data sheet, which describes the properties of the chemical substance, the risks of using it, what are the risks of using it, and also how to mitigate these risks. So why don't we have something like this for cybersecurity? We actually do now, thanks to the Electric Power Research Institute, based in the United States. They are abbreviated for EPRI. They came up with Cybersecurity Technical Assessment methodology, which is shortened for TAM. They also worked with other parties like the Sandia, National Labs, and they really spent a lot of time and effort putting this framework together. You can get the framework report at the link on this slide. And also I put a couple of emails from EPRI people you can contact about obtaining this report. Now, let's take a closer look at how this actually works. So, in total, there's 3 steps that are present in this framework. In the first step, which is also first half of our cybersecurity data sheets, our mission is to characterize attack surface and identify exploit sequences. So what this means is we need to understand how our system works, how it functions, and then we have to put ourselves in the shoes of some attackers and think about how they can break the system, how they can exploit it. So on the left side here, what we have done at OSIsoft is we took a typical network infrastructure like here. We have a Pi system, Pi vision, and other typical Pi components. And then we turned that IT diagram into logical data flow like we have on the right side. And here we actually see how the components talk to each other, what kind of protocol they are using, what kind of port they are using, and how the data flow actually goes in between those components. So this is a good base for understanding our attack surface and what exploit sequences exist in our systems. So in the framework, which is basically an Excel sheet, we list all the possible attack pathways, which basically identify how somebody might be able to get access to our system. So here we have a few where somebody might be able to use network connection to connect to data archive and try to modify Pi data, for example, or steal Pi data. We also included some operating system issues that could come up, for example, here somebody might want to compromise a system boot image. So all of these are listed, and it takes a long time to get these done, but once you have a list, that's something you can work with. Now, before we move on to the next part, we have to understand what exploit sequence is. So exploit sequence is achieving an exploit objective through attack pathway and exploit mechanism. So to give you a better example, here we have an objective where you want to modify time series data flowing from data collectors to Pi data archive. So somebody would like to modify data to actually get in between, modify data, and then this would impact our decision-making process. So attack pathway is wired connection. So they need to be on the network to be able to get in between our data collectors and data archive. And the exploit mechanism is man-in-the-middle attack. So there are tools available freely to anyone or to anybody who wants to exploit these things. So this is just an example of how exploit sequence looks like. So the good thing about the time framework is that it's bounded, meaning that you know when you are finished. There's 28 different classes of exploit objectives. So they are based on direct action, like getting physical access to your host running your virtual machines, or critical data. Somebody might want to steal or modify your operational data, user data, or security data, either in transit or at rest. So that's good about this. Now there's 5 different attack vectors. 2 of them are network, so this could be wireless or wired connections that somebody might want to exploit, physical access to the device, supply chain, and also portable interfaces like USB. So this is very comprehensive framework. It's not the easiest one to get started with, but once you spend some time on that, it really pays off. So then in this framework, we have 28 different classes of exploit objectives, like we discussed. So these are all listed on an Excel spreadsheet. And then we have to decide if that exploit objective actually applies to our asset. Because this doesn't have to be used just for software like Pi system, but you can use it for your hardware controllers or anything that you want to protect. So some of them might not be applicable to all your assets. But for those that are applicable, we have to assign our attack pathways that we identified to these exploit objectives. And this, in total, gives us our exploit sequences. So this is the first step, really understanding our asset and how it can be exploited or hacked. In the second step, which is also the second half of cybersecurity data sheets, we have to look for some security control methods to mitigate those exploit sequences that we have identified in step number 1. So we not only have to find these methods, but we have to decide how efficient they are, if it's something we want to implement, because some of them might be very good, but also very expensive, and we have no resources for implementing these. So going back to our example where we wanted to modify data in transit from our interfaces to data archive, we have to look for any protections that are available by the vendor of the application or the operating system or any other applications you are using. And here we do have a method we can deploy to prevent this attack. It's PyNet transport security. So this goes back to one of our big 4, where if you enable strong authentication, Windows authentication, then automatically we get transport security. So by enabling that, we make this exploit sequence something that cannot be done very easily. It would be very difficult for somebody to get through transport security. So this is just one example. Of course, there's going to be many, many different exploit sequences, and we have to set target levels for these. So we have to decide how important is it to protect against that exploit sequence. How important is it to be able to detect that somebody is trying to go through that exploit sequence? And how important is it to be able to recover if somebody successfully exploits that sequence? So that's what we do for those exploit sequences. And then for our methods that mitigate these, we have to calculate its overall efficacy score. How efficient is it? So the first one is protection. How effective is it at protecting against the exploit sequence? The same for detection and response and recovery. And then we have 2 more attributes there. Persistence, which means how difficult is it to overcome that method over time. Because yeah, there could be some method which is very effective right now, but over time its efficiency might decrease. So that's also projected into the framework. And last but not least is implementation cost. That's something I touched on briefly before. Some methods could be very effective, but also very expensive. So we have to balance all of those against each other. So once we make a list of all the methods that we have available at our disposal, here we have to score them and see how efficient they are. So here we have, for example, Pi backup, PyNet transport security, or some Pi tuning parameters we can enable. And then this is the same sheet. I just kind of split it for you to be able to see. So here we score all of those methods. So the result is a number. And we also look at implementation burden, both initial and over time. And finally, this gives us overall efficacy of the method. So those which are rated at 5 are no-brainer. We always want to implement those because they are usually quite cheap and very effective. 4s are very good, but when you get to number 3 or below, that's when you have to start making some decisions. Which ones do you want to implement and which ones are just not worth it? So then the last step of this second step is that we have a list of all our exploit sequences, and we assign multiple control methods to mitigate these exploit sequences. And then based on our target levels, because some of you use Pi in highly classified or regulated industries, these target levels could be different than for people who are using Pi just for some data which are not very important. So you have to set your target levels according to how important it is. And then we assign multiple control methods, and we see if we are at the level that we want to be, so we reach our target level or not. And of course, there's going to be some residuals present. That means that we are not fully able to reach the target levels that we set out to do. But that's to be expected at the end of this second step. That just means that we have done a good attack surface characterization, and we have scored our security control methods properly. So the result of those first 2 steps is cybersecurity data sheet. This is basically a structured documentation, security documentation. It's focused on modern platform and architecture. And one of the advantages that I see in this is that usually you are working in a team with some colleagues. You are not doing all of this on your own. And then if you need to bring somebody up to speed, this really helps because everybody can just open the spreadsheet and see exactly what your exploit sequences are, what the attack surface is, and how you mitigate against that right now. So this really provides a framework that you can build on over time. And then there's the last step, step number 3 in the overall process, where we have to address those residual exploit sequences, which have not been reached, or they haven't reached the target levels that we set out in step number 2. So these are called shared security control methods. An example of this could be that, for example, your data archive is running in a virtual machine, but that virtual machine eventually has to be hosted by a piece of hardware somewhere. And if somebody manages to get physical access to that hardware box, they can just kill the power, or they can just shut it down. And then all the methods that you put in place are not efficient anymore. So this is what's done on the department or organizational level. Usually it's shared across multiple data sheets. And once you do it on this level, the asset is considered to be protected. And now the nice thing about this is that if you are in a regulated industry and you have to prove to your compliance people that you are doing enough to secure your system, this really helps because you can show them that you have done your work, you understand what the risks are for your cyber asset and what you are doing to protect against that. So my call to action for all of you would be to contact OSIsoft, reach out to us, and we can send you our cybersecurity datasheets for PyVision and PyData Archive right now. They are still work in progress, but we would like to get some feedback from you, from our customers, just to see if it's something that you find useful and something you can use. In which case, we would like to be able to provide these data sheets with our software as part of our supply chain. So in the future, if you download a new data archive, it should come with a data sheet like this that will list all the issues that we know of that could be exploited, and then it's up to you to implement the mitigations against that. So it would be called reference data sheet. And then you have to tailor it to your own environment, of course. We cannot cover everybody's systems. So here's my email. So please reach out to me, shoot me an email, and I'll send you those data sheets, and we can have a discussion, maybe a call to go through it, because it takes a little bit of effort in the beginning to understand how it works. But in my opinion, it really pays off over time. And in the end here, I also put some useful links of stuff that I referenced across this presentation. So the first one, I think the most important, is our OSIsoft Cybersecurity Hub page, which is available on our customer portal. Once you log in, you'll get to a KB that links to many other useful articles that could be of use to you. And then there's other stuff from Microsoft and EPRI. So that's it from my side. Thank you very much. And now I'd like to take any questions.
No questions? Oh, at the back. I was going to say, it seems like everybody's very secure. Say your name and company.
Hi, thanks. I'm Martin from Rollos. Quick one. What's the plan? We use the scripts. We like the security scripts. I like that you've built this Excel audit tool around it, in a way. Is there any ideas to make this into an actual product with a UI, like the monitoring solution was for managing multiple PI systems? Or
so the actual framework is not provided by OSIsoft. It's done by EPRI. The Electric Power Research Institute. As far as I know, they are actually working on moving away from Excel to something a bit more usable for people, but their main motivation behind this framework is not to make money. It's quite cheap to actually buy the report. You buy it only once and it applies to your whole company. But definitely, if you are a partner or integrator, you could use the framework to build your own baselines that you can then apply to your customers. And maybe it will not really make you any money directly, but you will save time on implementation and deployment for sure. And also, you will be able to provide your customers data on how things are secured and what the risks are. And then it's up to them to accept those risks, or they have to do additional methods or add additional security control methods to prevent those exploit sequences.
Thanks.
Any other questions? No? In that case, I will be delighted to tell you that there's a reception in the expo area where you can go get snacks and drinks. But if you could give Lubos a round of applause first, please. Thank you.